Hello. So we are back, but this time let's speak about the most common mistake in laptop repairs, especially laptop repairs, yeah? MOSFETs. Testing MOSFETs, okay? So, especially for beginners. Now, I really understand you get the multimeter and you try and check the MOSFETs. Okay, MOSFETs are switching semiconductors and they are carry out of current. They can get shorted sometimes. Now, I swear this is the most common mistake. This is the most common, yeah? Now, this video came from the fact I was reading today the Discord. You know our Discord. You must be there if you are on electronics, yeah? And I was checking, someone was trying to test MOSFET. And, with the beeping and diode mode, and people are trying to learn. And that's okay, it's nothing wrong with that. So someone is trying to check some MOSFETs and was beeping. It's a long discussion about MOSFETs. Anyway, someone said here, beeping MOSFET in a circuit means close to nothing if you don't know what you are measuring, and that's very true, yeah? Now let's have a look today on our board here. We have a laptop motherboard, and what we are testing is MOSFETs, yeah? And you will check a MOSFET. How you check a MOSFET? 1 second. Can I zoom this? No, I can't. Let's go under the microscope and let's have a look. So what we are checking exactly? We have a MOSFET. We have 2 MOSFETs. Usually a power supply has 2 MOSFETs. Now, what we are checking? First, you have to read the configuration. So, you have 4 pins soldered together. You can see those pins are soldered together. If you try to measure with a multimeter, it's beeping. Those are soldered together. It's nothing short here. I mean, you can see short, but they are soldered together, okay? Then here you have 3 pins soldered together and 1 pin separate, which is the gate. Okay? Let me take out the reflections a little bit. Okay, so one more time, you have 4 pins together. You have 4 pins together, and you have 3 pins together, and you have gate. Usually the MOSFET gets shorted between source and drain, yeah? In this case, source and drain. Doesn't matter, you don't have to remember. Just check those 3 pins or those 4 pins. And people are testing like that, yeah? And you can see on the multimeter, which is on a diode mode right now, you can switch it to ohms, but it's not really point to check on ohm mode. Yeah, check on diode mode. So on the diode mode, we have nothing. You can see 0. I mean, infinite resistance. And you will think, okay, this MOSFET is good. And you will test the second MOSFET. And let's test the second MOSFET. Same 3 pins together here and 4 pins together here. And you are testing here, and it's beeping. You can hear it's beeping, and you have like 5.6 ohms. You found the fault. You found the shorted MOSFET, right? One more time. You can hear the beep, and you can see on the ohm meter you have 5.7 ohms. Okay, let's remove that MOSFET out. Quickly, and let's check the MOSFET out. Because that's what you will do on the next step, yeah? So, let's say a beginner, not you. A beginner, that's what it will do on the next step. Next step, you will remove the MOSFET. Okay, so the MOSFET is out. Let's test this MOSFET. Okay, let's test the MOSFET. Drain and source, yeah, we're checking for short, yeah? So check from here to here, and you can check on the screen, you have 0 ohms. So 0 ohms here, 0 ohms here, 0 ohms here. So this is the most common mistake. I always said, the MOSFET, the gate, it's capacitive. So you can check this MOSFET and you say, okay, it's shorted. With any pin, it's shorted. Doesn't matter how I check, yeah? it will show me it's short because the gate is capacitive. We cannot test a MOSFET on this way. I can discharge the MOSFET. It's very simple, yeah. So if I short the gate with the source, yeah, I'm discharging the MOSFET. So if I'm checking now, if I'm testing out the MOSFET, you can see it's not beeping anymore. Has infinite resistance. But if I take the power supply, yeah, I will take the power supply. I'll take the power supply and I have source and gate. Now if I check with the multimeter, it will show me it's shorted. So check here. 0 ohms, you can see? 0 ohms. Now you have to understand, I use the power supply to open the MOSFET, to drive the current, or to close the MOSFET. Depends how the people are using this. But if I don't have gloves, if I take the gloves out, actually you can make this MOSFET driving the current with your hand. You understand? That's how sensitive it's a MOSFET. It can get opened by electricity. Even if you take your screwdriver and you rub it a little bit around your hair, you can trigger the MOSFET so you can drive the current. So you understand, you cannot test the MOSFET on this way. The right way to test a MOSFET, if you really want to test it, I mean the right way. If you want like a quick test, you can easily just short, yeah, the source with the gate, and then you can check with the multimeter. But the right way to test a MOSFET is using a resistor between the gate and the source, yeah. So to keep any charge, to keep it to send it to ground, okay. But anyway, you took out the MOSFET, you figure it out, you've seen this video, and then you go back and you check your board. Yeah, that's what you will do next. That's what you will do. That's what a beginner will do. Okay, I checked the MOSFET. I found a short. I will replace the MOSFET. Doesn't matter. But even if you replace the MOSFET, you go on the point where the MOSFET it was. You take the multimeter. You come with the multimeter here, and you see it's short. Even without the MOSFET, you will see actually here it's a short. If you can see on the screen, 5.3 ohms. I mean, don't get me wrong. 5.3 ohms is far away to be a short. It's actually a normal condition. So this MOSFET is part of this. You see this coil is part of this power supply, which is supplying V core to the processor. Now let's quick draw a schematic to understand from where that 5 ohms comes. Okay, so we'll draw the schematic. So what we are checking, yeah, we found not this MOSFET, we found this MOSFET around 5 ohms, right? Because you check from here and from here. And from here to here you have 5 ohms, right? Now, just pay attention here. You have the processor, you have the CPU here. And here the CPU, from here to ground, has, how much do you think? 5 ohms, right? Like on our case. So basically, the ground is the same with the CPU. Okay, so you have 5 ohms with the ground, from the V core to ground, and you have the MOSFET ground, you have the source pin. But the drain is connected straight to the CPU by this coil. Yeah, so this is just a coil. So basically what you are checking on the drain and the source of this MOSFET, you are checking the CPU. That's the reason why when you are checking this MOSFET, actually you are checking the resistance of the CPU. Okay, this is the CPU, but you will have the same feedback even if you check to the GPU power supply, yeah, or I don't know. But just have it. This is very tricky, and I found that a lot of people, they are getting confused. They are checking the MOSFET, and from here to here they are getting like 5 ohms from drain to source, and okay, the MOSFET is shorted. They are taking out the MOSFET like I did. You test the MOSFET and you find it shorted. Then you replace the MOSFET, and the new MOSFET is again shorted on the board, but it's not short. You have a 5 ohms here, Another confusion is actually this MOSFET is like, I never found this MOSFET shorted. If you have a problem, let's say your power supply it will die, this MOSFET from here, it will get shorted, this one. Because this one, it will do a harder work compared with the bottom one. Okay? But how the switching power supply is working, probably will be interesting on a separate video. I'm just trying to point to the most common mistake. Now the CPU have 5 ohms. This is another confusion, and I seen on the comments from the last video. Now the electronic components, they are behaving different in idle mode compared when they are working. So for a 30 watts CPU, so your resistance will be, so we have 1 volt, and we know the resistance, which is 5 ohms. And right now, the power of the CPU, based on what you checked, you checked, and it's 5 ohms. Your CPU is taking 0.2 watts. And you have here a 30 watt CPU. Now let's calculate for a 30 watt CPU. So we know the power, we don't know the current, we know the resistance. No, we don't know the resistance, sorry. We don't know the resistance. We know the voltage, and we need the output power, yeah? So calculate, and we have a 30 watts, 30 amps current, yeah? So 30 amps current, and the resistance is 0.03. The only problem is you cannot test this resistance. This resistance, it will be achieved with the CPU fully loaded. You cannot test this. So when you are checking 5 ohms, you are checking a CPU on the idle mode, not even idle, like it's off. Okay? So if you think 0.03 is a short, is thought that's a normal state of a CPU working. Short has different meanings. Okay? So I will stop this. I just want to point to the most common mistake because I seen that on Discord. Thank you for watching. Like and subscribe if you like the video, and see you on the next one. Bye.